Hi, good morning and welcome to this, the last in our series of webinars on industrial networks. In this instalment, we're taking a deep dive into network security zones and conduits. My name is Ian Kilner. My role here is Key Account Manager for the Southern region. And I'm joined today by networking guru and all-round good guy, Ed Stanier. Good morning, Ed.
Morning, Ian. Thank you very much. And morning, everyone listening.
Good. So, without further ado, we'll just have a look at the agenda for today. So, today we're going to look at what security zones are, how we define them, and how to configure them. We'll then move on to conduits, which are the secure links between the zones, why we need them, and again, some best practice around configuring them. Lastly, we'll look at some example architectures and have a look at how we implement those architectures securely. So without further ado, I'm going to pass over to Ed.
Thank you very much, Ian. Okay, first thing we're going to have a look at here is a kind of traditional flat network. And we're going to have a look at this just to kind of show the wrong way in which to do things from a network security point of view. So when we look at a flat network here, we're essentially showing what's a network that's completely open, all devices connected to each other. All devices kind of share the same physical and logical segments.
Okay, so could you clarify what you mean by in inverted commas, a flat network, as it were?
Yeah, sure. So we're basically looking at, imagine a flat network as our one and only zone. So when we look at zones, we're looking at different parts of a network that are segmented away from each other. And when we talk about flat networks, we're essentially saying this is our one and only zone. There's no real way for us to kind of approach any real methods of security when we've got a flat network. Essentially, every single device within the network can see each other. There's nothing stopping us from adding security control lists, access control lists, that kind of thing, or any kind of filtering to stop devices from being able to talk to each other.
Okay, so if I got that right, as an analogy, it's a bit like an open plan office, and perhaps someone walking into that office and shouting across that office, everyone in that office can hear what they're saying and everyone can respond to them.
Yeah, exactly, and that's a perfect analogy for it. And when we talk about that from a network point of view, we talk about broadcasts, Ethernet broadcasts, which are essentially one of the main protocols we'll use in an IP Ethernet network. And by having this traditional flat network, we're allowing these broadcasts to be heard by absolutely every single device within there. So there's no segmentation, whether from a physical or a logical point of view, so whether that be physical or when we say logical, we're talking IP addresses, VLANs, that kind of thing. There's no segmentation whatsoever. Everything can see everything. So we'll have a quick look at the reasons why that's so bad. And the main reason is that there's no easy way for us to implement any real kind of security within a network. And the reason for that is we don't have any boundaries. So there's no layer 3 boundaries. There's no layer 3 devices, whether that be a layer 3 switch, a router, or a firewall. There's no device that sits within that network that will allow us to filter traffic between devices. So that only leaves us with a couple of options. The first option would be for us to be using software firewalls on the devices. And software firewalls, they're not particularly efficient. When we're configuring lots of software firewalls, it's hard to administer, hard to maintain. They're a lot more susceptible to vulnerabilities and that kind of thing. And failing that, the only other option really that we've got are MAC-based access control lists. So when we're looking at a flat network, everything is being switched, nothing is being routed. And because of that, the only security access control lists we can put in place are on the MAC address level. Now, they are extremely hard to implement. MAC addresses are obviously very hard to remember and to use, unlike IP addresses. It's a very hard solution to scale. In most cases, it's just impractical. MAC-based access control lists do have a place in some parts of the network, but firstly, what we want to be doing is defining our zones and configuring the secure conduits between them. So that brings us on to zones, and when we talk about zones, we're essentially talking about a group of devices, whether that be physical or virtual, and these group of devices reside within the same kind of logical or physical segment, and generally speaking, a zone and a group of devices within it, they should share a common kind of security requirement. So one way in which we would approach defining zones is by looking at different areas of our plant, different areas of our network, and defining common groups that require high levels of security, medium levels of security, that kind of thing.
Okay, so just going back to my open plan office analogies, a zone effectively would be like installing a soundproof booth within the open plan office and then using a secure telephone to connect those different booths together.
Yes. Exactly, that's a perfect analogy, yeah, absolutely. And obviously from a network point of view there, how we'd translate that would be, let's say, different VLANs or different IP address ranges being our zones or our different parts of the office. And the telephone part of the analogy, those would be our kind of conduits that we would obviously allow the certain types of traffic through to talk from one zone to another. So really, the hardest part when we talk about zones and we talk about defining them is how we actually come up with them in the first place. You know, how do we say what should be in what zone, how many zones should we have, and that kind of thing. And there's two real ways to approach this, and it really does depend on your organisation, your processes, your plant, that kind of thing. So there's no single answer here. It's on a case-by-case basis. But really the two ways to approach it are by looking at plant area grouping. And what we mean by that is we obviously have common parts of our plant, different parts of our plant for different processes. And that's obviously going to depend upon what it is that the organisation does. But in a lot of cases, there's kind of clear demarcation between different parts of a process that we can commonly group together. And that is one way in which a lot of people, a lot of security experts will start defining these zones. And the second way, and this is perhaps a little bit more common in smaller networks, smaller plants and that kind of thing, is defining zones by grouping common devices together. So what I mean by that is if we only had a small handful of PLCs, small handful of servers, workstations, for example, we may define a zone for each one of those. So a zone for our PLCs, a zone for our servers, a zone for our clients. Now there's no, as I say, there's no kind of straight answer for this question. It is the hardest part about defining the zones and understanding them. So really it has to be approached on a case-by-case basis, but these are just two kind of starting points for people to look at when we do look at defining them. So obviously defining zones, this is a first identify step in the NIST cybersecurity framework. So when you are looking at approaching cybersecurity for your organisation or for a customer, the first step really is for us to identify, and that is for us to kind of understand what we have and understand how we're going to define our zones, how we're going to group devices together and that kind of thing. And for us to do that, obviously, we need expert knowledge of a plant and the processes within it, because we need to understand how the process works from start to finish and how we can translate that into a network security point of view.
Okay, so it sounds like a first step would be an audit, perhaps.
Yeah, absolutely, and yeah, it's absolutely crucial we do an audit and we understand what we already have, because in most cases, and particularly on larger size networks, ones that have kind of evolved and grown over time, we don't actually know what we have. We may have a rough idea, but we need to fully understand the devices we have, how they're linked together, the current security we've got in place, and only then, once we understand what we have, can we start defining how we need to move forward, how we need to define these zones. And one of the first important things about when we have decided on kind of the groups of devices that we want to look at and that we want to put into zones, we need to look at the security requirements for them, because really a zone should have a kind of common security requirement applied to it. And what I mean by that is we shouldn't be mixing devices that require high security with devices that require very low security into the same zone. So one of the fundamental things in defining a zone is this common security requirement within there. So we may have a bunch of PLCs that are extremely kind of high criticality to our process, or we may have a bunch of legacy devices that have got inherently very low security, and we need to obviously apply maximum security to those because of that. And again, that would be another perfect scenario for a zone within itself. And what we're not trying to do here on this webinar is obviously recreate the wheel and try to confuse people, because obviously there's a huge amount of information already out there. So a good kind of base point to start looking at security levels and how they refer to your grouping of devices or your defining of zones is the ISA 99 and the IEC 62433 security level section in the ISA documentation, and you should have a link there that you'll be able to use. It's a nice PDF document. It's quite in-depth. It's got lots of kind of flow charts to help you understand how you should look at security levels, how you should define them, and it goes through lots of different questions about what would happen if these devices were offline, how important to your plant is it. And once you've kind of gone through them flowcharts, you can start applying different security levels to different parts of a plant and different devices within it. So we've had a quick look at how we would define zones, how we would group devices together and that kind of thing. So now we're going to have a little look at the two kind of main ways in which we would configure zones. And really the two most common ways are through physical or logical segregation, or sometimes a mixture of both. But if we just start with looking at physical segregation first, so this is essentially grouping devices together and connecting them to the same kind of physical switch, the same physical segment of a network. Those switches in turn would then connect to our layer 3 device, where we configure our conduits, and that would be where we provide the boundary for the zone. Now, the problem with a physical approach is it doesn't give us a lot of flexibility or scalability. So we're going to have a quick look here at an example of a physical segregation of zones. So let's say we've got 3 zones here. We've got a demineralization zone, a core production zone, and a packaging zone. We've got different IP address range for each of them. They're all the devices within each zone is connected to the same switches. Those switches in turn connect to this layer 3 switch in the middle of our topology. So this layer 3 switch essentially would provide the connectivity for each of our zones. So the only way that a device in the packaging zone could talk to a core production zone device would be by going through this layer 3 switch. So it's at that point we can start implementing some security controls, some access control lists and that kind of thing. Obviously the issue we've got here is that we are bound by these kind of these physical boundaries here. So for example, our packaging devices have to reside, they have to be cabled back to the same packaging zone switches. And if we also want to start growing our network, scaling it up, we've obviously got to then start configuring additional links to our layer 3 infrastructure, our layer 3 switch, or our firewall. So this kind of scenario is not particularly flexible or scalable. It does work, and in some cases this is what you will see implemented. But really the way, the most efficient way and the most scalable and flexible way for us to approach configuring zones is through logical segregation. So that's what this topology represents here. So imagine our previous topology, we've got our 3 different zones. What we've essentially got here is we are allowing each zone to reside anywhere within the network. So we've represented it here to say, well, any zone, any device within any zone can reside within any layer 2 switch within the network here. So we could have a mixture of devices in each part of a network. We could have our demineralization zone devices scattered around the network, same with our other 2 zones. So no longer are the devices constrained by the physical location. We can put them absolutely anywhere within the network we want, which obviously makes life a lot more easier, a lot more convenient for us as we start scaling the network up. Much like if we wanted to add additional zones, providing that we have the port capacity for it, we don't have to start buying new hardware, we don't have to start buying or running additional links to our layer 3 infrastructure. This would be through the use of VLANs. So we would essentially be using trunk ports between our switches into our layer 3 switch there in the middle, and for us to create a new zone is as simple as configuring a new VLAN on our network devices, giving it a new IP address range, and obviously configuring the access ports to use that VLAN, and then obviously connecting the end devices into it.
Okay, so just going back to my analogy one last time, effectively a physical architecture would be where you have each department in their own zone, physically staying there, and the only way to contact them would just to speak to them in that specific zone. Yeah. Whereas in a logical architecture, you could perhaps have hot desking, so you can still contact the people, but they're able to move between the zones, and you can still contact them securely within that specific zone, as it were.
Yeah, absolutely, and yeah, it's a perfect analogy for it. Yeah, just like hot desking. So if we wanted to move a device from one location to another, we would just move that to another switch, configure that switch port to be a member of that zone or that VLAN, and that's it. Off we go. Simple as that. So this is obviously the much more efficient, flexible, scalable way for us to configure zones through the use of VLANs, and it is just as secure as the other approach. So sometimes people look at VLANs, you might look at this and think, well, surely that can't be as secure, but that's a bit of a fallacy, and VLANs are just as secure, providing they've been configured in a secure way, and the switch management has been configured correctly as well. Then using VLANs is just as secure as a physical approach as well. Okay, so we've had a little look at zones, how we define them, how we configure them. So now we're going to look at conduits. And when we talk conduits, we're essentially talking about the links between the zones, the secure links between the zones. And we use these to control access to the zones and provide a security border, ensuring that network traffic is inspected and filtered before it is allowed into the zone and the devices within it. So when we talk conduits, we're essentially talking a little bit like a whitelist. So we're talking about when we configure a conduit, we configure certain types of traffic, certain protocols, we allow certain devices through, and that is essentially our whitelist. So the device that controls the conduits, in most cases a firewall, will have this list of rules, this whitelist of rules, and it will allow only those types of traffic through.
Okay, so just going back to a recent experience perhaps again, so this reminds me of my parents recently got a call minder installed on their home phone. Effectively didn't tell me. I rang them up a week later, and effectively what a call minder does is effectively the same thing. It's a whitelist of people who are allowed to contact you. If your name's not down, you can't get hold of them. I ring them up, this automated voice says, could you state your name and your relationship to the family? So I confidently state Ian Kilner's son, and guess what? Denied. So yeah, it's just important to make sure you configure those whitelists correctly, and it's very important to make sure the right traffic gets through.
Absolutely, and I'm sure that example there was nothing personal in. But yeah, you're absolutely right. And sometimes that can be one of the hardest things when you're configuring the conduits is understanding the traffic that is actually required. But the protocols, the port numbers you need to allow through, that is normally the hardest part of it. Quite often it's easy to miss certain network types of traffic, and that is most common as well when you have, let's say, a weekly batch job or something that only runs, every few days or once a week or something like that. When you're doing your testing and you're defining your conduits, it may not be something you pick up on. And in that case, yeah, similar to you, where you got denied, that traffic would not be allowed through as well. So it's important when you are defining your conduits to, be very thorough about it, be very methodical, test again, ensure that you haven't missed any parts of the process, and all the traffic is allowed through. And I won't go into it too much now, but there are certain ways in which you can do that, certain tools that can kind of help you with it. A lot of firewalls offer like a learning mode feature, which essentially runs as an open channel that starts collecting a log file of all the different traffic types being allowed through. You still have to do some filtering on that yourself, need some kind of human verification to go through it and say, well, this is genuine, this isn't. But there are ways in which you can make life easy for yourself. Another way would be to use Wireshark, which I've used commonly in the past to kind of start monitoring the different port numbers being used, because not all kind of SCADA packages or you know, plant packages, software packages you'll use will have good documentation and will tell you specifically these port numbers, these protocols. Some just won't have that documentation, and then the rest is up to you to find out what it is. So just going back to where we would implement conduits, we're talking these would be configured on our layer 3 device, normally a firewall. So essentially the device in which our boundaries are defined, and in most cases where the routing takes place, let's say if it's on a firewall or a layer 3 switch or a router, that's where we would implement our conduits. And the most common kind of feature when we talk conduits is access control lists. They are what give us our whitelist. And they are essentially just an ordered rule set in which we specify the types of traffic that are allowed through there. And by default, everything else is denied. So there's like an invisible denial rule at the bottom of these access control lists. If we haven't specified it, then that traffic will be dropped. Now, we can do this filtering through any number of ways. Most typically, we do it through IP addresses, protocols, port numbers. We can kind of get more complex if we wanted to, and we can start filtering by certain options in the IP header and the TCP headers, UDP headers, that kind of thing. But most commonly, we'll be looking at IP addresses, protocols, and port numbers. Those are the three main things that we would configure in an access control list. So we'll have a quick look at just some best practices when configuring these conduits then. And really the goal of setting up our zones and conduits is to make our network as secure as possible, to reduce our surface area of attack as much as we can. And with that in mind, what we want to do when we configure the conduits is only allow the necessary network traffic through and absolutely nothing else. And we obviously make use of this implicit denial rule at the bottom. So some people approach access control lists in allowing large amounts of traffic through. What I mean by that is by allowing an entire subnet to talk on a certain protocol. We want to kind of avoid that, because we only want to allow the devices that are actually needed to use that protocol. So you can get quite lazy when configuring access control lists and just say, right, allow this entire zone through, I don't care what device it comes from. But in actuality, there may only be 2 devices in that zone that need to you know, access that service on the other end. So we want to be as specific as humanly possible, lock it down to the individual IP addresses that are required, the individual ports that are required, individual protocols that are required. And also, our bottom point here, areas of high criticality that require extensive levels of security, they should have multiple conduits between them and insecure zones such as DMZs. And we'll have a look at an example of what we mean by that. But essentially, if we've got a super important part of our plant, we don't want that directly connected to our edge router. We don't want it accessible through one conduit. What I mean by that is we don't want to just have to compromise one device to get access to our plant, super critical part of our plant, which, you know, we need up 24/7. So let's have a look at our first example. So what we've got here, if we start from the top and move our way down to the bottom, so we've got essentially we've got our zones there defined in our kind of coloured circles, and our conduits are defined with our kind of orange coloured pipes, if you will. So what we've got here then, our external access zone is secured by a conduit to our firewall, that first device at the top. And that has other conduits to a DMZ zone and the rest of the network. So I'm not sure if you can quite see on the diagram there, but we're just allowing our VPN and secure HTTP traffic through that first conduit. And we're then allowing HTTPS, again, secure HTTP traffic into our DMZ zone. So imagine we may have an external or internet-facing web server there, and the only traffic allowed from external is secure HTTP into, let's say, a reporting server or something in our DMZ zone. Moving further on down there, we've got our layer 3 switch, should we say, in the middle there. We've got access control list set up on there. So again, we've got conduits here just allowing HTTPS traffic through. So this is a super secure network in that very little is allowed through. We're making use of a secure protocol here, HTTPS, and imagine we're using one of the later SCADA packages that makes use of that and is able to offer a lot of functionality through a web browser. So we've got HTTPS allowed through there to our supervisory and server zones. Perhaps we've got web servers there, so from our server zones we may need to access a web server and a DMZ, but nothing else is allowed through, so there's no devices here with kind of outbound internet access. And then further down the chain there, right at the bottom, we've got our supercritical control PLC zone, and that's secured further by an additional firewall there. And all we're allowing through that conduit is OPC traffic. So let's assume we've got a SCADA or Wonderware application server in the server zone. That's then talking to some kind of data gatherer in the control PLC zone through OPC, but absolutely nothing else. No other traffic is allowed through to that control PLC zone. So we've got kind of a highly secure network there. So in that instance, we've obviously got our two firewalls. We've got our layer 3 switch, which provides our boundaries for our kind of supervisory and server zones, and we're just allowing the bare minimum of traffic through there, HTTPS and OPC. So now we'll get a little bit more complicated. And we've got some kind of additional layers in here. So we've got similar to what we had before, except in this instance we've also got an extra zone added. So we've got corporate connectivity here. So there's devices in corporate or people in corporate who want to start accessing some statistics from our plant and the processes within it. So we're allowing a further conduit in from corporate there, HTTPS traffic. Again, that talks to, let's say, a reporting server within the DMZ zone, but absolutely nothing else. So no traffic is allowed to or from corporate through anything other than HTTPS. So we've got a high level of security there. We've got a secure link between our plant and the corporate zone. And what we've also introduced down at the bottom there is a couple of additional zones. Let's say we've got a substation PLC zone and a wireless zone as well. Now, the wireless zone here, let's imagine we've got some wireless tablets or devices on the plant floor that need some kind of reporting service, or they need some functionality there and some secure functionality to be able to access, let's say, an application server in the server zone. So again, we're just allowing our HTTPS traffic through our conduit there. So our whitelist would say, right, these wireless clients can talk to this server in the server zone. Here's the IP addresses. The port number would be 443 TCP. Everything else is denied. Absolutely everything else is denied. We've got a secure link there between our wireless zone and our supervisory and server zone.
So I guess a lot of my clients, there's a hot topic of conversation around mobility and wireless devices. This would be a really good example of how to implement mobility and wireless devices while still maintaining a high level of security.
Absolutely, yeah. It certainly would do. And you know, obviously, just looking at this kind of high-level diagram, we can see the wireless zone now. It's kind of sat at the bottom of our architecture almost, the bottom of our kind of levels, our ISA levels. So really, we've got multiple conduits, we've got multiple devices between our untrusted zone, our internet zone, and our critical zones at the bottom. So we've got a kind of a much more secure approach than just having a flat network just hanging off an edge internet router there. And just to kind of put that scenario, that topology into practice when we talk about these ISA levels, we've basically got the same topology there, and we've kind of linked it, we've applied it against our ISA 95 cyber security levels. So we've got at the top there our clear demarcation. We've got level 4 corporate and DMZ zone. In the middle there we've got our level 3 plant network zone, which contain our supervisory and our server zones. And then right at the bottom there we've got our levels 1 and 2, the plant floor and access zone, and that's where our kind of high criticality zones are, our substation PLC, our production control PLC, and our kind of trusted wireless clients on the shop floor. And that's it from me.
Okay, great stuff. Thank you very much indeed, Ed. That was a fascinating insight into zones and conduits there. So we're just going to have a look at some questions. We have had some questions during the webinar. One that's popped up a number of times actually is a question around third-party access. So third-party remote access. What are the do's and don'ts around this? How do you connect securely into a network? I've personally seen a number of occasions where SIs have effectively open access into a system. They can connect to it whenever they want, and it's fairly uncontrolled. I've found that fairly surprising from time to time. So yeah, a few pointers in that regard would be useful, I think. So what's your advice?
Okay, it's a very good question, and actually I agree with you, Ian, that I've seen a lot of that, a lot more than I'm kind of comfortable with. And particular one I see is kind of critical application servers that have direct access to the internet, and we've normally got something like TeamViewer installed or LogMeIn or something like that. And that's kind of, it's exceptionally bad practice. I mean, TeamViewer does use a kind of secure channel, but to have a high criticality application server with direct internet access out and to authenticate using something like TeamViewer, that's certainly a don't. So any approach where the device that the SI or the maintenance engineer needs to connect to, any device they need to connect to, should not have direct internet access out. So when we look at do's, or when we look at a secure way of doing it, we want to start applying kind of multiple layers of security. And there's a couple ways, most common ways that we can approach that and things we can look at. And the first is kind of a token-based VPN. So this is obviously VPN being the industry standard for us to connect securely and use industry standard encryption. A token-based VPN would allow us to generate a one-time use code that gives the SI or the engineer an hour or however long they need to connect to our application server and do their maintenance work. That token obviously then expires, they can only use it once, and if they need to get back on, they need that human contact for us to allow it through. But moving on from that, there's other things we want to look at. The servers in which they connect to, we don't want to start giving them administrator access. We don't want to give them access to do absolutely anything they want to. Whether they have good intentions or not, it's a very big security no-no. So again, we can give them a secondary kind of read-only account after they've authenticated with a VPN, and again, this can be kind of token-based if we want, so just allow them a log-on for an hour or however long they need, and it would be a read-only account where the only thing they can access on the terminal server or on the application server is the software they need to do their job, to make their changes. So we don't give them power user or administrator access to start changing system settings, looking around the C drive. It literally just gives them the very bare limited access for them to do what they need to do. So really, again, it's the do's when it comes to secure access for SIs and engineers is to reduce the kind of surface area of attack as much as possible. Just give them the bare minimum of what they need and absolutely nothing else.
It's all about change control, isn't it, and the due diligence behind that and transparency to see who's made those changes as well. So it all feeds into that, yeah.
Absolutely, yeah.
Cool. We've got one more question, I think. This one's with regards to file sharing. So how would you recommend you look at sharing files from the DMZ down to the more secure network below?
There's a number of ways to approach that. It's a very good question. I suppose one of the things I'd be asking is, do I need my file share in the DMZ in the first place? And that's what I'll be looking at to begin with. There's secure ways in which we can offer file sharing. Again, we can use secure protocols to approach that. So perhaps we don't want to use the kind of built-in Windows file share, but HTTPS again can actually be used for file sharing, WebDAV, and that kind of thing. So, I mean, the first thing I'd look at there is, do we absolutely need to start file sharing between DMZ and a secure zone? Is there not a better way for us to do that? If the answer was, yeah, we absolutely need to do that, then we should always look at a secure channel in which to do that. So depending on what version of Windows you use, whether they're up to date, or if we're even talking about Windows here, will depend on whether we can trust the kind of file sharing protocols that Windows are using. But obviously I'd also be looking at very high levels of authentication here. So we certainly don't want to allow file shares that you know, have the everybody user group allowed and have read-write access to everything. Again, I'd be limiting the file share to the absolutely only critical folders that the end user requires, and I'd be enforcing some strong user and password policies in place, so we're absolutely certain that only the specified users can actually log on. And to take that one step further, perhaps if this was just a temporary file share that was required and we didn't need to kind of constantly use it on a day-by-day basis, then two-factor authentication is something else to really kind of add an extra layer and really bolster that security.
Okay, cool, good stuff. We have got one more question, or a couple more questions that come up, but we'll probably answer those offline. So I think we've run over a little bit, so I don't want to keep people more than is necessary, but so just to thank you all very much indeed for your attendance today. I hope you found the session informative, and hopefully it's given you some food for thought. Don't forget, we as a company offer networking audits, networking consultancy, and a full range of networking hardware, software, and security devices. So feel free to get in touch if you've got any immediate requirements, or indeed you want to have a chat about anything. So yeah, just once again, thanks very much indeed for your attendance, and have a great day, and hopefully we'll see you on the next webinar.